Okay, welcome to the MySQL talk today. My first question is there anybody really interested in me talking English? If you're all, yeah, okay, good. Then you have to endure my English accent, sorry. Okay, good, yeah, welcome to the MySQL talk, MySQL 8 document store. That is something new that we started with MySQL 8, which came out a year ago. So I want to introduce you to the options that you have with MySQL by not only creating regular relational SQL statements, but use a completely different way of accessing data. And this is what we will take a look at. So we all know the relational databases with all their benefits, like data normalization, constraints, ACID compliance. We are very proud of ACID compliance. If you commit data, it's really physically on disk and nothing can happen. And we have that really powerful SQL language, which enables you to do all kind of complex reporting on your data, very proven and developed over the last 20, 30 years. But many developers are not really big fans of SQL in some cases, because it can be quite complicated to do things and it's not that easy to get started with. So what do developers really want? They very often have an object approach. They use objects in Java, Python, whatever, and they just want to persist these objects. And they don't care about relations between individual tables. They have an object which includes an array or whatever, some kind of data collection, and then they want to persist that and do simple CRUD operations on their objects. Retrieve it, maybe modify a bit of the content, and do stuff like that. So very easy CRUD. CRUD stands for create, read, update, and delete data. Very simple basic data operations on data objects. So not thinking about schema design, but still, if we store data, we want to keep it safe. That's very important. I mean, then if we don't care for data safety, then we don't need a database. But we want to keep data safe and maybe use some of the concepts that are known from relational databases, like transactions or foreign keys or something like that. Let's see. I'm not a big fan of the term schemaless. It's a bit confusing and misleading. Schemaless means the database does not care what kind of data you're storing. But that does not mean the data is without any schema. It's just a different entity that needs to take care of the data schema. It is your application. You need to understand what kind of data is there. So schemaless just means it's not the database taking care of the database schema. It's the responsibility of the application designer. But from a database perspective, I just want to store any kind of documents. If there is an array in my object or whatever, I don't care. Just store anything. So what is very common in these scenarios where you work with objects but want to store it in a relational database are these ORMs, object relational mappings, which hopefully completely abstract from the relational model and give you that freedom of using or storing objects. What we aim for is using JSON as a data format, which is completely freestyle. I can use different ways. I can embed arrays. I can embed other objects within an object and stuff like that. Write all that in JSON and store that. So I want to work with JSON, so I can get rid of all these ORM mappings, which create a whole new set of problems and challenges. So we have these two different views of the world, the relational entity relationship diagrams, right? Strict structure and data types, and that more relaxed free form of JSON that I can store. These are the two worlds of the relational databases and what became the NoSQL databases or the document-based databases. So this is how DBAs see the data, usually their relational approach. And this is how developers see the data, that JSON data approach. So what's the right choice now? Should we go for a relational database like MySQL, or should we go for NoSQL? And our idea is actually, why not do both? And why not use one DBMS and use it for both use cases? And this is what we are aiming for, what we developed with MySQL Document Store. So we use MySQL with all the features that you know, relational tables, foreign keys, we can use generated columns, indexes on generated columns, transactions, and we combine that with the features that people seek in NoSQL databases, like JSON documents, up to 1 GB per document, schemaless JSON collections, and no longer the need to embed SQL strings in your application that send some weird queries in some kind of string that needs to be composed to a relational database. And from that, we created that X Developer API. So that's a new API to access data in MySQL. And we will take a look at that in a minute. That's good for using SQL with the full power of SQL, as always. But I also have a way of using a simplified CRUD interface that leverages that typical method chaining that we are used to from JavaScript, for example, Python, Java, whatever. I'll give you some examples in a minute. The MySQL server is actually the same MySQL server as before. So under the hood, we still use the InnoDB storage engine. We store everything in tables in InnoDB. But to the outset, we offer two ways to access MySQL. The standard protocol with the SQL API, the one that we all know, port 3306. But we have a new way of accessing, and this is why we open a new port, 33060, where we are listening to a new protocol, the so-called X protocol. And this one accepts SQL queries as well as that new API, that CRUD API. And when you use the connectors, you can choose whether you want to connect via the standard protocol on port 3306, or if you use the new protocol and connect to 33060. Both ports are definable, of course. And then if you connect to the new port, you talk all the connectors, and also the MySQL shell, the command line interface, will talk the new protocol, and you can use that new CRUD API. Nevertheless, whether you use this or this way to access data, you always have InnoDB tables underneath. So I can use two different ways to access the same kind of data. I can even use the simplified CRUD interface to access plain relational tables as before. And actually, when we talk about JSON collections, under the hood, it is a table with two columns, a JSON column and an identifier column. So that's a relational table as well, our collection. And I can use the X protocol and CRUD operations to modify JSON collections or modify relational tables. And I can even combine these two. They can coexist in the same database. So that X Developer API, that requires obviously support for the new protocol, and this is why all our connectors, C++, Java.NET, Node.js, Python, PHP, all these connectors do support both ways, the classic MySQL protocol as well as the new X protocol. And we have a new command line utility that helps, that better supports developing for this new API, and that is the MySQL shell. It is actually the same MySQL command line utility, but it is enhanced. It has 3 operation modes. We will take a look at that in a few seconds. And that's all that we need to make access to data a lot more flexible. So that Developer API, in addition to all of SQL, offers these ways to create, read, update, delete data. And if I'm accessing document collections, I have a method collection.add to store a new document, collection.find to retrieve some, collection.modify and remove. And if I access relational tables with more than just one JSON column, then I use the table.insert, select, update, or delete method. Now you get a first view of how it will feel and how it will look like to access that new API. There are no longer SQL statements, just a string that I compose. I use exactly a table object dot method select. And because everything is stored in InnoDB underneath, we have all the features that we are used to from MySQL readily available in a MySQL document store, in our document collection. So we have full asset transactions. We configure MySQL, or actually that's the default configuration of MySQL, fully asset compliant. So if you really store a document, then this document is physically on disk. Even if someone pulls the plug, your data is safe. We offer full transactions. So that was there from day one. Start transaction, then modify several documents and do a rollback or commit. It's all or nothing. It's a full asset compliant transaction. Because we run on InnoDB, right? And the new command line tool that I mentioned, the MySQL shell, it's worth taking a look at that because it offers much more than the command line tool that we used to use in the past. That does still exist, obviously, for backwards compatibility, but I really recommend going to the new one, to the MySQL shell. It has 3 different modes of running. The SQL mode is the one that we know from the old command line utility. But you can also run it in a Python mode, and then you can, it's a Python interpreter. And you can also run it in a JavaScript mode, then it's a JavaScript interpreter. And you can interact with MySQL directly via JavaScript. So you can use that for writing batch executions, whatever you expect from a command line utility, auto-completion and so on. The cool thing is we do have some helper objects integrated in MySQL shell. For example, the MySQL 8 upgrade checker. That is a utility that you can call in the MySQL shell and provide connection details to MySQL 5.7 server, and it will connect to that server and check if that server is feasible for upgrading to MySQL 8. So it will check the obvious things, for example, like did you use any names that became reserved names in MySQL 8, or any other changes. So it's a very good test of an existing 5.7 instance. What do I need to consider when I want to upgrade this to MySQL 8? So the more we develop on the MySQL shell, the more DevOps tool we will integrate into that. There are some more examples, not just the upgrade checker. We also use that MySQL shell to set up and administer the InnoDB cluster. That's the middle block on top. So setting up an automatic failover cluster of 3 MySQL instances. If you want to see that, come see me at the booth later on. I can give you a short demo of that. But that's not development API, that's why I skip that here now. One other interesting example of the MySQL shell is a tool called, it's a bit small, I'm sorry for that, util.importJSON. And then you just give it a JSON file. That file, you might have created that with a Mongo export from a MongoDB database. You define the schema, let's pick docstore and a collection name, restaurants, and some parameters. And then we can import Mongo export files immediately. So it's a very nice way of importing JSON data into MySQL. Under the hood, the MySQL shell will have created a collection, and that collection is in InnoDB a table with 2 columns, a JSON column and a unique identifier column, and then store the JSON documents row by row. Each document becomes 1 row in the InnoDB table. Okay, let's take a look at more examples. I do have a live instance, and I want to show you some examples of how to use that developer API. Let me just switch my screen so that you can see what I'm doing here. Because it's really no fun watching me typing, I have that little tool here that will help me it just copies that text line into the, so I can just paste it here. That's easier than me typing, but this is just for me, just ignore it. So when I want to start the MySQL shell, I have a MySQL instance running locally in a Docker container. I can connect via the URI. Root means my username is root, my password is root. Sorry, I'm not a security expert, obviously, as you can see. Connecting at localhost port 37010. That's not the default port. I have a very special port used here in my environment. To give you an example that MySQL shell is really supporting you to become better at security, let's remove that and I can show you a feature of the MySQL shell as well. And I will connect to the schema demo. So I need to provide the password, and you don't know the password now. And MySQL shell automatically offers to manage my passwords. So it will store this password and it will reuse it automatically. I never have to use it in any command line directly for scripting. I can fully automate that. It will be in an encrypted way used so that I no longer have any unencrypted passwords on my process list or in my scripts or whatever. So let's use that. Okay, and now I'm in the, is that large enough in the last row? Can you still read what I'm, yeah? The guys in the last row are a bit hesitating. I try to do a bit more. Okay, so now I see the prompt of the new MySQL shell. And you see it's great. We offer Unicode support for the prompt. You can make it colorful. It's not the key feature, but it's the nicest looking feature. I have even colleagues who added a small dolphin to the prompt. Yeah. One of these, Sakila. Okay, and you see I'm in the JavaScript mode. It's that JS logo with \SQL. I go to the SQL mode, and this is the one that we all know. So I can do a show tables. And you see I have a restaurant tables here. That's the one that I got from the import that I've shown you on the slide. So I can do just a show create table restaurants. This is why I usually copy the lines and not type. So that restaurants table, that's actually a document store collection. It's created by, on SQL, it's a column ID, var binary, the first column is doc of type JSON. Since MySQL 5.7, we have that data type JSON. And a column underscore ID, it's a var binary generated always, that's a generated column. That's nothing I can define in an insert statement. It's automatically generated by MySQL, and it's generated by a JSON unquote, JSON extract from that doc column, get the top level attribute ID. So it's browsing through the document, JSON document, retrieving the top level attribute ID, and stores that in my ID column here. And this is then used as the primary key. That's all under the hood. If you are using the MySQL as a document store, you don't have to deal with that at all. Let's go back to the JavaScript stuff. I always have a basic attribute, basic object called DB. That's my current database. And from that, I can very easily, for example, create new collections. So let's do something db.create collection posts. So now I have a new collection posts. And in that collection, I can store new data. dbPosts.add, and then I just give it some JSON document. Title attribute MySQL 8 rocks, text my first post, and the window, some parts of the window are outside of the screen right now. And an attribute code with the value 42, whatever that means. And let's add another one. Oops. So I added another one with the title polyglot databases, whatever. No code attribute. Freeform, each document can have different attributes, right? And to show you that it's really a JSON data type, I try something else, dbPost.add, and just a string. No, that's not a JSON document. It's just a plain string, and this will create an error. We only accept real JSON documents, right? And then I can retrieve this, for example, with dbPosts.find, and I can use another method, limit1, so only give me one of the documents back, same as we know from SQL. So I get one back. And I can also use some search, some filter queries, dbPost.find, and code equals 42. So look for the attribute code, and only if the attribute code has the value of 42, please report that document, and then I get back the one with the code 42. The other one does not have a code 42. And this is the way how I can simply access my document store via that new API. I use the database.collection name, and then the method find, add, modify, and so on. Now, if I have lots of documents, obviously I want to search for, if I need that search code 42, that triggered the full table scan. That's not a problem with just 2 documents, but if we have millions of documents, it might be less attractive. So we want to have indexes on JSON attributes. And that works pretty easy as well. db.posts.createIndex. And then I'm creating an index which I call title IDX, which is based on a fields list, $.title. It could be a combined index with multiple attributes, but I'm only using one attribute. Use the attribute title of type text20 and create an index from that. And now I have an index on that title attribute. Whatever document has a title attribute is part of that index now. And if I do a query and I'm querying for, we had that example with code equals 42, I could the same do with title equals or title like something. The MySQL optimizer will automatically leverage the index. I don't have to refer to anything like index or whatever. We are doing that in the background. I can show you what happened in the background. Let's go to the SQL side of the world. Show, create table posts. We have our doc column, our ID column, and then we have a new one with, that's definitely not my name for that new column. I didn't define that. Generated as JSON unquote, primary, JSON unquote, JSON extract doc $.title. So under the hood, MySQL created a generated automated column and extracts from the JSON document the title, puts that into this column, and then we have created a key on that new column. That's what happened under the hood. And the optimizer will use that index whenever possible. And I just did that very simple dbPost create index statement. And my developers don't have to care, is there an index or not? As a DBA, I could just add that index later on and no one has to care, no changes in the code needed for that. Okay, let's try something else. I do have transaction support. So let's create another collection called archive. DB create collection archive. And now I'm starting a transaction, session.start transaction. So whatever I do now is part of a transaction. At the end, I will roll back or commit, and everything is executed in total, or rolled back in total. Now I'm fetching one of the documents I have in my posts, and the code is actually 42. So I'm looking for the post, find code equals 42, fetch all, and I store that in a variable called t. I'm in JavaScript mode, so why not assign some variables? Let's take a look at what t includes. It's that document. It's in the collection, but I also have it in my local execution environment right now. And now we can add that to the archive collection. So db.archive add t. And we remove it from the posts collection. It's okay, it's the same attribute here. I could have removed the unique IDs as well. Looks cleaner to me, but anyway, it will work this way as well. So I have actually taken one of the documents out of the post and put it into the archive collection right now. And if I check dbpost.find in post, there's only the one without code 42. And if I do a db.archive.find, there's the one with 42. So I have two collections, each one has one document right now. But if I now do a session.rollback, I'm still in an ongoing transaction. I do a session.rollback and check again what's in my collections. Posts has both again, because I rolled back my transaction, and archive should have none. Yes. So I did two changes to two different collections, rolled back the transaction, and everything was reverted back. And other connections, what will they see from during my transaction while I had not yet the rollback? As always in a good database, that depends on the transaction isolation level. And you can define all four transaction isolation levels. Does a concurrent transaction see only the consistent state at the start of the transaction, or does it see data as it is modified, or only data that was committed? The same principle applies to the document store as well. Other connections can see only data that is committed, or other transactions can see all data as it is being modified. So I have a document store, but I can use the relational features as well here. Okay, some other interesting queries. The cool thing about SQL is that complexity of queries that you can do, right? So let's do some interesting reporting queries. db.get collections. You see I have three collections. Actually, I only created archive and post, but I also have that collection restaurants that I've imported at the beginning. So I will work with this collection right now. We can just check restaurants.find.limit1. Let's take a look at one of the documents in that collection. You see some of the attributes here. It's defining restaurants in New York City with an array of scores, so some evaluations. The first one is DJ Reynolds Pub and Restaurant, and the one attribute that it will be interesting for us is in the address, the borough and the cuisine. So what type of restaurant and in which district, which borough of New York it is. And now I want to do some reporting on that. So let's take the really complex one. I can do some easy reporting on collections in that development API directly. So I can do a group by, I can do account star, all these simple aggregations. These are available in the development API as well. But if I want to do really complex things, I have the full power of SQL. This is what I said at the beginning. We want it both. We want a simple CRUD interface which offers basic reporting functionality, but then we want the full flexibility and power of SQL as well. So let's go to the SQL interface, and we can use this interface to access that collection as well. So let's do a really complex query, and that's something new in MySQL 8 as well. Common table expressions, or with queries. With common table expression 1s, and then a subquery, select from that document, top level attribute name as name. From the document, the top level attribute cuisine, that's the second column as cuisine. And then a subselect where we do a JSON table. This is where we create the average grade for a restaurant. So we are creating a subtable or a derived table from that array of individual grades and doing an average of the score of that. And the next interesting feature in that select with that subquery, we are doing a ranked over partition by, that's windowing functions. So we can create, we are partitioning by cuisine. So for all the French restaurants, we are calculating the medium rating and list the top restaurant. So the query in total gives you for each type of restaurant the best rated of its kind. Then we find that there are some JSON documents with strange values. That's an interesting feature as well. I can discuss that in a minute. But that's the result. So which is the best Iranian restaurant in New York? Which is the best Polynesian restaurant in New York? And this was just one query with common table expressions, with windowing functions, all the powerful SQL features available to report on document databases. If you know how to write that query in MongoDB, I would be really interested to see how that looks like. And these error messages here, by the way, come from the fact that the data set that I imported has JSON documents, and in some of the ratings, there's not a rate of 0 or 5.0, but 5.0, which is fine for a JSON document, but kills you in reporting. This is why some people prefer relational databases. Then you know a number is a number. And it's not just a JSON document which can contain anything, even an O instead of a 0. These complex queries that you can write, I have another example which has absolutely nothing to do with document store, but it's a great example of how powerful SQL is. Features that you always needed. The output is very large, so I have to reduce the screen size here, the character size. Why isn't it reducing? So you can write SQL queries to calculate the Mandelbrot set, which is absolutely useless, but really interesting. So I like that example very much. That's one simple SQL, it's not simple, no. That's one SQL query, and it really shows the power that you have with SQL. So you can do even crazy things like that. But I will go back to the larger screen and try that in MongoDB. I don't know why, but try. Okay, and the last example that I want to show you, I have a few minutes left, good, is what is the benefit of mixing the two? I mean, there are applications where I need a document store and there are applications where I need a relational database. Why should I do both with MySQL? That's actually something you can gain from combining the two. And for that, I give you an example how to modify relational tables with the new development API. I go back to the JavaScript mode now. I do something which is a call session.sql. That means for my session that I have to the database, send an SQL query. This is how I use full SQL via the development API or via that new X protocol. So I call session.sql. Create table borrows with two columns, with one column name, varchar 20 primary key. Plain old MySQL, right? So I create a new table called borrows. And if I check database, get tables, I only have one table. Actually, I have archive, posts, restaurants, and borrows. I have 4 tables, but 3 of these are actually collections. That's why they are not listed in get tables. I do have DB get collections where I see the other 3. But table is borrows is a real table. And now that I have this table, relational table, old style table, I can use dbborrows.insert. It's not .add, that would be for a collection, but this is not a collection object, that's a table. And for that I use insert, in the column name, the values Manhattan. So I store one row with the value Manhattan. And let's do some more. You can even chain these, so insert Staten Island, Bronx, Brooklyn, Queens, and missing. So now I have a table, should I have that? Yeah, okay. Now I have a table, let's do the select star order by name. I have a table with all the boroughs of New York. And now I just do it and then explain. The next one is I do again session.sql, alter table restaurants. Restaurants is a collection, but on the SQL layer it looks like a table. We add a column to the restaurants collection that we call borrow, varchar 20, automatically calculated as JSON extract doc $.borrow. So from all the JSON documents, extract the top level attribute borrow and put that into my new column, which I call borrow. That means nothing. I still have a document store. I just have that extra column. I could create an index on that now, but I skipped that part. And the next step is session.sql alter table restaurants, add foreign key, table borrow, column borrow references, table borrows, column name. So I do a referential integrity check from that borrow column in the restaurants table to the borrows table that I have created before. Now I have a document store with referential integrity. So if I add a new restaurant, database.restaurants.add, that's a document collection here. I add a new JSON document, name Mario's Pizza, borrow Milan. which is not part of New York, I get an error. I cannot store a document into my document store collection which violates the referential integrity that I have defined. So I have a relational table, I have a document collection, and I can create referential integrity between the two. And hopefully I can still store documents, Mario's Pizza and Borough Brooklyn, because Brooklyn exists in the other table. That's fine. And that's the beauty of combining the two. I can use the features that I know from relational tables and use that selectively in my document store. That is the big idea behind that. There's one other reason that I want to mention briefly. I try my best. I just need to go back to my presentation. So there are reasons why people prefer NoSQL solutions. For example, that simple access pattern, just collection.add. I just use my object in Java, make it JSON, and do collection.add. And then I have my object stored in a database without the need for any object relational mapping with all the problems that might arise. I can use ad hoc data formats. I can add new attributes to new documents if I like, or I can remove it, whatever. I have very simple operations. I can even tune MySQL in a way that it prefers performance over consistency. I can do that in MySQL. By default, we value consistency much higher, so full ACID compliance. But I can configure MySQL so that I don't care for data consistency too much. I want more performance. And in some cases, I need the SQL power or the old relational features, like complex queries. I want join operations. I didn't show you the example. I can do joins between collections, obviously, as well. I can do ACID transactions. I have well-defined schemas and a rich set of tools for all these environments. And what we are doing with MySQL is actually combining the two, running in the same MySQL process. If the developers want this, okay, here's MySQL, use it. If developers want that, okay, here's MySQL, use it. And the operations people have only one environment to take care of. They know how to do online backup of MySQL. So that means they know how to do online backup of the document store or of a relational store. We know how to do monitoring, support, all the stuff. We automatically have an SQL firewall auditing, encryption, authentication for a document store as well as for the relational part. The whole environment is the same environment as always. The complete ecosystem, you can use the complete ecosystem of MySQL to run relational and document payloads, or even combine those, as I've shown with that foreign key example here, combining a document collection with a relational table. And combining these two worlds and give you just one product that gives you all the necessary features. This is what we aim for with MySQL 8. So empower the developers and make life for operations people easier. Any questions that we can clarify in the last 0.5 seconds? There are two possible explanations. Either I explained everything fully and you fully understand everything, or it was really hard to understand. If you have any more questions, just see me at the booth. We can discuss everything. I can show these demos again. I can show you how to make this highly available with just 3 statements in create cluster, add node. With 4 statements in the MySQL shell, do it in automatic failover cluster, or discuss any other questions you might have on MySQL. Thanks a lot.